All right, so let's start chapter 12. Chapter 12 deals with the cardiovascular system. In this chapter, we're really just looking at the heart. Now, the heart is found in our thoracic cavity. If we go to this next picture here, this shows a little better. It's found in our thoracic cavity. It's off to the left side a little bit, roughly about right here in your chest, and it's roughly about the size of your hand. All right, so if we continue on here, now let's take a look at the pericardium, which is the covering of the heart. And you can see that there's many layers here of that pericardium. So the first, shown here in this kind of whitish layer right there, that is known as the fibrous pericardium. And so this is a loose-fitting sac around the heart that is made of fibrous connective tissue. And so one of the main functions here is it protects the heart. So anytime we have a tough fibrous connective tissue covering around an organ, it's going to actually prevent infections from getting to that organ. All right. It also, because it is made of tough fibrous connective tissue, it's not really stretchable at all. And so this actually helps prevent the overfilling of the heart. So the heart can only expand to the fibrous pericardium, and then it has to stop. All right, next is the serous pericardium, which is a serous membrane or serosa around the heart. Now, there are two layers to that. We have this blue layer they're showing here, which is on the fibrous pericardium, and that is called the parietal pericardium, right there. So as I said, it's on the fibrous pericardium. And the other, the visceral pericardium, is on the heart itself, and they're trying to show that with that red line there. You can't really see it over here, but all right. Now, remember, serous membranes, they double back upon each other, and so this creates a cavity between those two serous membranes there. And so that space right there is called the pericardial cavity. Now, both these membranes are going to produce serous fluid, and if you guys remember back, serous fluid is a lubricant. So when our heart is beating, our visceral pericardium is moving into parietal pericardium, and both of those are producing that serous fluid, so it really reduces the friction here. All right, let's take a look at the layers of the heart. So this is looking at the wall of the heart here. And the outermost layer is known as the epicardium. The epicardium is also the visceral pericardium, so it's the same layer. Underneath that is the myocardium. This is the myocardium here. It is made of cardiac muscle tissue. All right, so this is the middle layer of the middle muscle layer of the heart. And then lastly here is the endocardium. So this is the endocardium here. This is the inner lining of the heart chambers. It is made of endothelium, which is the same thing as simple squamous epithelium. And this is continuous with the endothelium that is found in our arteries and veins. Okay, so let's look at the parts of the heart. This is looking at an external anatomy here of the front of the heart. And this is looking at an actual heart. The next picture is showing the back side of the heart. All right. I'm going to go to the next picture, which shows us like the inside, because I'm going to talk more about this stuff here. Now, when you're looking at these pictures, a couple things to note. Red indicates high oxygenation. Blue indicates low oxygenation, not the actual color of the blood. It's always red. All right. Also, this is the left side. This is the right side. It's as if you're looking at somebody. All right. So these upper chambers up here, those are called the atria, and there are two of those. So these are the chambers that receive blood returning to the heart. Now, these are very thin-walled chambers, so you can see there the walls there are pretty thin, and I'll explain that in a minute. All right. So the right atrium receives blood returning from the body. And the left atrium receives blood returning from the lungs. So that blood has just been oxygenated, so that's why we see that reddish color there. All right. Next are the ventricles. These are the ventricles down here, right ventricle, left ventricle. All right. These are chambers that pump blood out of the heart, or force blood out of the heart. They are divided by the interatrial septum. Now, there is a septum that divides the atria as well. But I mention this here because we're going to mention it later on in this chapter. All right. So the left ventricle pumps blood up and out to the body. The right ventricle pumps blood to our lungs. All right. Now, if you look at these chambers down here, these ventricles, they are thick-walled chambers, versus the atria are thin-walled chambers. Because the atria are just going to push blood down into the ventricles, where the ventricles are going to push blood up and out of the heart. The right ventricle, as you can see, has thinner walls than the left atrium here. And that's because the right atrium is pushing blood to our lungs, which are just right here, right near the heart. Where the left atrium has to push blood out to, your fingers and your toes, and really all up to the top of your head. Pushing against gravity requires a lot of energy. All right, next are the blood vessels of the heart. So if we move to this picture here, first are the coronary arteries, shown over here in red. These are arteries that supply blood to the tissues of the heart. All right, so if these get blocked up, that's what's going to lead to a heart attack or a myocardial infarction. Next are the cardiac veins. So here are the cardiac veins here. So these are veins that drain blood from the tissues of the heart. All right, so they're going to drain into the right atrium. So now let's take a look at the valves. So let's go back to this picture here. So here we see 1, 2, 3, 4 valves there. All right, so the first are the semilunar valves, or SL valves. So the first is the aortic semilunar valve, shown here. So that aortic semilunar valve, this is between the left ventricle, right here, and the aorta, so that major blood vessel right there. Now, in actuality, that valve is a little further down, but on these pictures, they move it up so we can see all of them. Next is a pulmonary semilunar valve, located here. So this is between the right ventricle and the pulmonary trunk. All right, so this valve, what did I want to say about this? So blood is going to be pushed through there. Now, the whole reason for valves is that they prevent backflow. That's the purpose for having valves. All right, next are the Atrioventricular Valves. That's these two valves here. Oh, I remember what I was going to say. Is that the order in which I showed this, or said this, from the pulmonary semilunar valve between the right ventricle and the pulmonary trunk, that's the direction that blood moves as well. All right, so next is the tricuspid valve here. So here's a tricuspid valve. That's between the right atrium and the right ventricle, so blood's going to move in that direction. Over on the other side is the bicuspid valve, also known as the mitral valve. And so that's between the left atrium and the left ventricle, so blood moves in that direction. All right, now, with the tricuspid valve, you can remember that that's on the right side of the heart because there's an R, went the wrong direction, there's an R in tricuspid, all right? Now, if we go to the other side, well, there's not an L in bicuspid, but there's an L in mitral, so you can think of that's the left side there. All right, now, both of these valves have these little stringy-like things attached to them, and those are called Chordae Tendineae. So these are collagen cords that attach to the papillary muscles in the ventricular walls. So these are papillary muscles here. You can see those there, and those are attached into the ventricular walls. All right, so what those are going to do here, all right, and so this is showing it when blood is entering the ventricle, right, so the ventricle is filling up. But now when the ventricle is going to push blood out of that chamber, these ventricular walls are going to contract, which is going to make those papillary muscles contract, and that's going to pull on the Chordae Tendineae, and that's going to help close those tricuspid valves so that blood moves through those semilunar valves. So this is going to help prevent backflow into the atria. All right.